Welcome back to our channel. I'm Teacher Cedric, and today we are going to look at another NMOS special round questions from the year 2010. Now, we define the ending zeros of an integer as the number of zeros at the end of the integer. For example, 2010 has one ending zero, whereas 10010000 has four ending zeros. How many ending zeros are there when the value of this product is simplified? Now, before we are going to tackle this problem, let us first think about, where do ending zeros come from the first place? Very good. They come from multiplying with 10 or multiples of 10, 10, 100, or 1000. Now, a quick example would be, if I have the number 201 times 10, then I will get an ending zero. If I have 1001 times 10,000, then I will get four ending zeros. But is that the only way where we can obtain ending zeros, only tens? The answer is no, because we can further split the number 10 into 5 times 2, which means if I can find some 5s and 2s in this product, then with the 5 and 2 multiplied together, then with a 10, I will get an ending zero. Now, a question naturally arises is that, what if the number of 5s and 2s does not match? What if I have a product that looks like this? How many tens or ending zeros can I get? The answer is just 3, because for every 2, I can match with another 5. With another 2, I can match with another 5. And then there will be this remaining 5, which cannot make up any 10. Before we see that in this case, the one with less numbers actually decide how many ending zeros we can get. Now, coming back to this original problem, our task now is to find how many 5s and how many 2s are there. And then let's look at which of them has less. So think about this. Do we have less 5s or do we have less 2s in this product? Very good. The answer is less 5s. Because for every 2 numbers, 16, 18, 20, I will get a multiple of 2, an even number. So of course, there will be more 2s than 5s in this product. So now, the number of ending zeros would be determined by the number of 5s in this product. So let's find out how many 5s are there. Let's see. Now, starting with the number 16, we see that for every 5 numbers, there would be a multiple of 5. And then for another 5 numbers, I will get number 25, which is another multiple of 5. So from 16 to 210, every 5 numbers, there will be 1 5. So I can simply take 195, which is the numbers from 16 to 210, divided by 5, put them into groups of 5, and then I'll get 39 groups. So if each group contains 1 5, there will be 39 5s. But can one number only contain just 1 5? That's the question. And the answer is no. For example, some numbers do contain 2 5s, such as the number 25. So we still have to find out how many such numbers exist. Now, if 25 is the first number that contains 2 2s, so we can look at from the number 26 to 210, every 25 number, there will be another 5. So for every 25 numbers, we can find a number that contains 2 5s. And the first 5 of this number have been counted in these 39 5s. So now we can take 185, which is the number from 26 to 210, divided by 25. So we get 7 such number. So with this 7, I would have counted those second 5s in those numbers that contain 2 5s. Now, here's the question. Can a number contain 3 5s? The answer is yes. We have the number 125, which consists of 3 5s multiplied together. So how many such numbers exist in this product? The answer is just 1, the number 125, somewhere in this middle. So with this number 39, I would have counted all the 5s, including those first 5, and the number that contains 2 5s and 3 5s. And with this number 7 and this number 25, I would have counted those second fives in those numbers that contain 2 5s. And with this 125, I would count the third 5 in those numbers that contain 3 5s. So all in all, I have 39 plus 1, the 25, plus 7 from here, and the 125, this number will get a total of 48 5s. Now, there will be more than enough 2s for me to pair up with these 48 5s to give me a number 10. Therefore, at the end, we will be able to attain 48 ending zeros as the product to this. Now, this is a very useful technique whenever the question asks you about ending zeros. And it is worth remembering that 10 is made up of 5 times 2. And if the numbers of 5s and 2s does not match, then we look at the one that has less numbers. That will decide how many 10s and ending zeros we will be able to obtain. Now, if you'd like to learn more about NMOS, RI, or SMOPS question, make sure you join our study groups on WhatsApp. And our courses include weekly math classroom from P1 to S2, as well as short-term sprint class for PSLE, NMOS, RI, SMOPS, SUSMOL, and SMKC. And you can download our app by scanning this QR code over here. I'm Teacher Cedric, and I'll see you soon.